Hello, everyone, and welcome. It is Wednesday, and the Knowledge Bolide Crew has assembled for yet another Meteorite or Meteorwrong. I don't know why it looks like Halloween, but there we go. This is the time of the month where we get all of our Patreon supporters on the rock counter level. If you don't know what that is, read the description of this video, and we actually help them identify their rock. Is it a meteorite? Is it a meteor wrong? Or does it need more testing and more eyes on it? So that's what we're going to do today. We have several examples, but first we have some fun stuff planned with a little happy birthday wish, belated as it is, but happy birthday, Marissa. She's been on our crew since the very beginning, and everyone is on mute at my request. That's why it's so quiet. But trust me, there's like balloons and banners and sprinkles. It's crazy. So happy birthday. I know you just turned 21, so enjoy your first alcoholic drink, okay? Also, we have a little call out to Greg, better known as Gary. No, Greg. Greg Shanos. He is a astrophotographer and got the Walter H. Haas Observer Award for his work of photographing the transit of Titan. So we're going to be talking about that after we stop recording today, but we want to definitely get those call outs to the crew because when we say the crew is strong, the crew is wise, this is what we're talking about. We are jumping right into Meteorite or Meteor Wrong number one. Sue, can you tell us about this one?
I sure can. All right, our first submission was sent to us from Chris R., who supports us on Patreon and YouTube. And he has a message for us. So I thought this was really nice. So Chris believes our rock identification membership's a great opportunity for people. He feels that Topher, the crew, all of us are making a really big impact on science by fostering enthusiasm and building a strong home scientist culture within the field of meteoritics. And has also pointed out that nobody else is doing what we're doing right now. So
See,
thanks so much,
I
Chris.
told you.
Appreciate that.
Yeah, that's super awesome. And I've been saying that lately. Like, no one else is doing this, man. Like, honestly. So good. Thanks, Chris. Appreciate that, man.
Right, so this specimen was found in a stony, like clay-like environment in northeastern Indiana. It weighs 22 grams, and for its size, Chris thought it was pretty dense. He did do these diagnostic tests. They're just not performed on camera. So we had dark gray or black for the streak test, and it was strongly attracted to a magnet.
And just so you know, for my ex-wife's size and weight, she was pretty dense too. So sorry.
They're all on
Go
mute. I'm sure they're laughing.
Yeah. Go
So Chris reported olivine and orthopyroxene. Also, some divots that he believes to be regmaglyphs. He mentioned there were some cool colors and metal revealed when he cut the meteorite. And he also mentioned that if he had to guess, it was a mesosiderite C, which is one of nine, and he thought it was similar to NWA 1827.
We always ask our submitters to like tell us what you see in this rock. Why are you thinking it's a meteorite? What features stand out to you? And then we always ask. It's the Allison test. What kind of meteorite do you think it is? You know, it fits into one of three columns mainly, and we usually ask that. So this guy actually went ahead and said, "Hey, man, it's not only a mesosiderite, but I know it looks more like this. It's a rare one, 1827." So I think we have some pictures of that.
Well, I kind of wanted to share what the
Oh,
exact
yeah.
definition of a mesosiderite is, and obviously brecciated meteorite containing subequal silicate and metallic components. And this isn't the mesosiderite C. This is just the general mesosiderite. So, yeah, silicates are dominantly igneous rock fragments, and I believe I could be wrong, but I believe Chris had mentioned that he wasn't 100% sure about everything that he was claiming. And I think I told him, like, yeah, don't worry about it. Just like tell us what your gut instinct is. And we would really love if all the rock counters did that. That way we can kind of see where they're going with it and what their perception of the rock is. So this
Hmm.
is the one that he kind of it reminded him of the rock he found.
And you actually got some nice pictures of this that actually look like his sample too. So very good. All
And you,
right, crew.
Topher, you
Uh,
just got one of these too, didn't you?
yeah, I did. Uh, Crew, we're going to start the video now. Please take notice of different things. If you see something that you want to talk about, by all means, raise your hand and I'll come to a few of you guys. We'll get your opinions on what we're looking at and hopefully identify terrestrial features. Extraterrestrial features would be nice. And then if we can identify what we think it is, if it is a terrestrial, a what terrestrial? We do have some pretty interesting looks at submissions today. Like this looks really weird. It look on the very, very top, you can almost see like a straw, like uh, spinettes, or I don't know if that's what it's called or not. Oh, there's a close-up of them. We have Allison first out of the gate. Wow, it looks like gold in there. Interesting. What do you have, Allison?
This is a beautiful sample, Chris, and I can see why it's caught your attention. Uh, to me, the silicate inclusions are too green to be a mesosiderite. I'm not familiar with any that are so vibrantly green. And also, I am not sure that I can agree with Chris that there are regmaglyphs on the outside of this. I'm not seeing anything that looks like regmaglyphs on the outside of this stone.
Okay, thank you. I appreciate you
Mm-hmm.
pointing out the color. Like it almost looks like these are like gold and there's gold colored. This is like a more of an iron color. Um, but we do have a nice dispersal of metal that is uh, seen in some mesositerites. Um, Dave, were you going to offer some information?
Yeah, one thing I wanted to add about the exterior is I didn't see any sign of fusion crust. Uh, However, the interior is very intriguing, but I have absolutely no idea what the orange yellow material is. But the
Hmm.
it does look like a mesosiderite, but those inclusions are puzzling to me. And that's what I got.
Thank you, man. Yeah, I don't know what the formation of these are, but that structure looks unique. We do see some vesicles, some obvious rapid cooling, and I hope I'm not going to steal Mike's thought, but I actually think I may see some kind of like of a separation line running along here, separating this material from this material. Um, but I'm going to bow out to Mike Kelly. What are you seeing here, buddy?
So you had mentioned the straw color on there, and I want to touch on that. And you also mentioned the vesicles or porosity in there. I was keying on that, and what I was noticing is those straw-colored crystals are very needle-like, and they look like they grew into void spaces, which is
Oh,
something you really wouldn't see in a meteorite. So I think you're looking at a slag there, and those crystals are indicative of growth, not in a vacuum. Um, you know,
so does this? I don't mean to interrupt you. Does this, from the side view, support your hypothesis? What you're thinking
yeah,
of it
yes,
growing?
I think they formed after. I think it's a broken piece, so that's part of a larger mass. But just the fact that those individual crystals aren't incorporated, they grew into a free space and they're of that
Yeah.
size. To me, that's not something you're getting in a meteorite.
Thank you very much. I appreciate that. I'm really glad that you were able to pick that apart and say, hey, that's a terrestrial thing, and it took time to grow there. It's been on Earth for a while, but it doesn't. Nothing else really looks besides the dispersal of metal on the interior. That's the only thing I'm pointing to is seeing it looks like mesosiderite, and we're seeing obvious signs that it's not a mesosiderite. You're not going to see those voids and vesicles in any mesosiderites necessarily. It's not a common feature. Pat, did you have anything to add before we get out of here?
Only that the vesicles are not spherical. They're stretched into weird shapes, and that's not typical for meteorites. The vesicles are rare in meteorites, but when we see them, they're almost always spherical. Thank you, Topher.
Thank you. Does anyone else see structure in this, or am I the only one that sees? Well, like maybe I'm seeing flow or something. I don't know, but yeah, it doesn't look mesosideric to me. But this is a really good video, and here's a good shot of those intergrowing grains that Mike pointed out. Yeah, really good. This is a great example to bring to attention because of the metal dispersal. But when you see the metal dispersal along with these vesicles, that's very, very telling of slag. And then we have like almost a layer in here where there was a void that stuff grew into. So besides not seeing anything on the outside that really talks to us, I think we're going to go with the crew saying this looks like a piece of slag. Smelters waste, metalworking waste, something like that. Sue?
I wanted to add that we're always asking the rock hounders, please send your videos in ASAP. Don't wait till the last minute. That way I can work with them. I will say Chris's, this was his third video. The first video, I already told him, sorry, bro. Like it was not good. It had a lot of challenges. He got everything fixed in the second video, but he forgot to do it in widescreen. This third video is such a major improvement over the first one. And Topher loved it so much that he wanted to feature it first. So it does pay to get your videos in ASAP. Don't wait till the last minute.
Thank you. Yeah, and this is diagnostic. This video we can actually work with. We know, we're not guessing. We're seeing everything. So good on you, Chris. Thank you very much. Sue, who submitted Meteorite or MeteorWRONG number 2? And by the way, who does number 2 work for?
I knew you were going to say that. Well, number 2 is Fernando, who is a returning rock hounder. He's worked with us before on a rock submission, so he's back. He sent a message. Well, it was something that he had recorded on his video, but as you guys know, we mute the videos now so we can talk over them. But he mentioned he wanted to say hi, and he mentioned Topher and I and Pat and Allison and the rest of the crew. So like a lot of our viewers say, he knows that we don't know him, but he feels like he knows us because he's been watching these videos for quite a while.
Yeah, I really appreciate those kind messages. It's really, really nice to get those messages. And yeah, we do strip them off so we can talk over your video. But I've also changed. I want to make sure that our rock hounders know that we've kind of changed the way we do the rock IDs. Before, I never looked at anything prior to the show. I went into the show blind, the crew was blind, and we would just go it together. And now I'm actually involved the night or two before, looking at the final presentation, looking at these things, getting my own opinions of them. So if I've already spent a good 15, 20 minutes on each of these submissions. So I really want to make sure that our rock hounders don't feel like we're just foot on the gas running through these things. If anyone objects to anything we're saying, they will raise their hand, they will stomp their foot, they'll throw it in chat, we will stop, we will make it right. So that's just something I want to say, that I've looked at all of these in advance. Sue and I have spent a lot of time with these already prior to the show. So just in case you feel like we're moving through, we got to. It's YouTube. Sue?
Oh yeah, yeah, we've spent a lot of time on these. All right, so Fernando found this in the southern region in Spain, the Andalusia, I think that's how you say it, region, on a property that he recently purchased. It's a little over 2 kilograms with an extremely strong attraction to a magnet, and he did perform the streak test on camera. I believe that he turned in 2 different videos, and one of the videos it looked kind of gray, and then the other video, it looked reddish to me, but he said red, so that's what we're going with. He provided the density himself. He had mentioned chondrules, and he did point some fusion crust out, but it was on the video that we didn't use, and it was on a really small screen where he was kind of not microscopic, but really, it was just there was no way I could blow the picture up, but he believes that he did find some fusion crust.
6.19, that's pretty dense. I'm not going to
Yeah,
any more
definitely.
jokes. Yeah, no.
Yeah, wait till you see how the magnet reacts.
Oh, okay. And we can see on the screen here we have a magnet test, nickel test that proved positive for the presence of nickel. I told Sue when this picture popped up last, I love that scoop. I would put, if this is a meteorite, I want it on my shelf because that is a good looking sample right there. When we get into the video and we start talking, maybe someone can offer some information about microscopic analysis or our rock counters including this information.
Those were some of those microscopic pictures that weren't really included, but since he mentioned chondrules, I wanted to, grab a screenshot. So
yeah, if this is helpful for any of them, I don't think these are microscope slides. I think these are just close-up photos. Very interesting. Like the texture of Mars over here on this side. Always coming from the rock hound point of view. These are quality photos, but I want to say happy birthday, Marissa. You're still going to be the employed photographer for the crew. Your job is safe.
She set the bar really high.
All right, so now we're actually looking at the sample. It looks to be a massive hunk of iron, and I like that big scoop out of it. That was something that drew me in right away. I have 3 hands up, but I only see one name, so I'm going to go with Daniel Shake. See what you have to say about this.
How's it going, Topher?
Very well, man.
Awesome. So I had just a few comments on the texture that was shown in a few of the images previously. It looked like I did see a contact between 2 different kinds of textures that may be present in this rock. Now, whether it may lend some guide into identifying what it is, I can at least say that one of the textures looks very fine-grained, almost similar to something you find in, basalt rocks, which are just volcanic rocks we find on Earth, but can also be found in other planetary bodies like Mars, Moon, and of course Vesta. The other thing I noticed was one of the other textures looked like almost like some kind of what we term poikilotic texture in igneous terminology, where you have one mineral that's enclosing another. But it's interesting given that there are vesicles that it appears to be present in there. And there's some other phase that I'm not quite recognizing as something you tend to find in igneous rocks. So I'm a bit puzzled, to be honest, by this rock. And it may be some kind of unusual breccia. So I can't really comment on terrestrial or not, but I can at least say it looks like some kind of breccia, and it would be good to make an additional slice just to see more of the inside up close. That'd be my 2 cents.
Very interesting. Thank you, man. And your 2 cents is worth 2 cents, so I appreciate it. Daniel Shake is our classifier to the stars, so we'll always go to him first. Pat, what you have for us, buddy?
Yeah, so the overall shape of this one does look good. The density that he's measuring is really very high. It's way above hematite and magnetite. There does appear to be a metallic luster to this piece showing right now and to the end where it was cut off, but the metallic luster looks a little dark. And he was asking about chondrules, but nickel iron meteorites do not have chondrules. They're differentiated. That's what I had. Thank you.
Thank you. And Pat, I'm going to steal Allison's thunder. That's Allison's test. I'm going to let her do it. Go for it.
Yeah, basically, Pat summed up what I was going to say in the very last thing. This, to me, I was so delighted. My chin just about hit the floor when I saw that first picture where you're like, check out the scoop on that thing. I was like, it's an iron. Oh my gosh, it's an iron. And then I looked at my notes, which again, Fernando, we're not zooming past you or hurrying through. We are listening and taking notes. And it says chondrules. And I thought, heck no, we cannot have chondrules in an iron meteorite. So again, if it were a meteorite, to me it looks more like an iron, or maybe even more like a meso. I mean, maybe just being speculative, but definitely when we get into those microscope pictures, which I can't say much about, except I can say that with that much metal, it's probably not chondrules. So
Yeah.
that was just my thing. It does not look like a chondrite, but it doesn't not look like some kind of an iron to me. But Pat did make some good points in that, and so did Daniel. So I'd have to agree with the fellas and say this is some kind of very interesting earth rock.
Thank you, guys. And gals, I appreciate it. Does anyone else have any? I this one annoyed me. I'm sorry. This was a very cool look at a feature right here that I thought could be diagnostic. It's a unique feature on this sample, and right as it was coming up, he puts his thumb right over it. I was like, "No, con!" I
He's
wanted
not
to look at it.
exaggerating.
No, take your hand. Oh, okay. Yeah, so I'm seeing some vesicles and voids on the outside and on the interior. I do like the shape of the outside, and I also like the shape of our new guy, Anthony. What are you seeing in this one?
Well, I was just gonna add on the density issue there, and he said it was around 6, but if it were a stone, right, with chondrules, it would be much lower than that, and if it were an iron, I think it would be a little bit higher. So something doesn't match up there. So I'm agreeing with y'all.
It would have to be a mostly metal mesosiderite, I think. I'll go ahead and say maybe take another slice off of it. Since you are connected to us on Facebook, you can put a picture on Facebook. But unless we see something totally different, we're not seeing anything that pulls us in other than the sexy shape on the outside. Because yeah, when I first saw that first picture, I was like, "Holy crap, we might actually have one here." So
that's a really
sorry.
good looking rock, really good looking submission.
Yeah, thank you. Well, it wasn't mine, so yeah, but we're getting a good bunch of submissions every single month, and a lot of varying ones too. All right, we are moving on to rock ID number 3.
Okay, rock ID number 3 came from another Chris on down in Florida. So Chris found this specimen, and he lives just north of Tampa, by the way, about 30 or 40 miles. So he found this specimen right after a hurricane, and he had mentioned in his email that he found it in sugar sand. And I'm not familiar with what that is, but I did find out. And it's, yeah, really powdery, really fine, and there were no other rocks in the area. It was really out of place. It's a really big rock. It weighs 28 pounds, but it's very dense, no attraction to a magnet, and I don't think he performed a streak test on it. So he had mentioned on his video that he was not sure if he was looking at fusion crust, but he thought he was seeing it and that it had melted into itself. I wasn't sure if he was talking about the fusion crust or the rock. He said he felt like it was too heavy to be a lava rock. So yeah, let's take a look at the photos and the video.
This is one that I have. I think the crew has a high probability of possibly identifying.
There were some small fragments and other rocks that, I mean, it's a large rock and it has some crevices in it, and other rocks had fallen out, but we looked at the pictures.
we can't.
There was no way we could
look at those.
determine if it was part of the main rock.
Yeah, we never want to take a sample that supposedly fell out of a hole, a crack, or crevice of your sample and say it's the same. We'd much rather look at this massive 28-pound piece and just, hey, if the thing that fell out is exactly the same, it's exactly the same as this. So let us look at this one. I'm going to let people hold their hands up. What I'm noticing right off the bat is the rounded and bulbousness of it. It looks like every like it looks very bulbous. There's bubbles and rounded shape to it. Allison, what do you have for us?
Chris mentions that on his large stone here that he thinks he sees fusion crust. And I want to address that really quickly, that fusion crust, if there were, I would assume that right now as he stood that up, that if this were a flight-oriented stone in any way, that would be the backside of it. And we don't see a fusion crust that flows from front to back or anything. The entire stone seems to be covered in said crust. And to me, that is going to eliminate that being a fusion crust, but also there are so many lumps, bumps, vugs, and holes that to me it just really screams slag.
Thank you very much. I'm looking at this and it almost looks like the wall of a cave with
Yeah.
stalactites and how it's dripping down. That's that's the first look, besides the bulbousness of it on one side and this side looking like dripping wax or the inside of a cave. Dave, what do you have to say?
Yes, absolutely. It looks definitely like slag. The important thing he had mentioned, there were no other rocks in the area, and this is what appeared. Well, that's what generally happens. Slag gets dumped, and it was just dumped there, and all of a sudden, there it is. And so, yeah, I can understand how you can think that there is slag, but everything else looks so weathered. It couldn't be a fall. It's it looks like a rust type stuff on there too. But really, I'm getting really a lot better at recognizing slag.
Yeah.
It really does.
Yeah. And thank you. And what I'm learning through this too is there's a bunch of different types of slags out there because there's a bunch of different metals, a bunch of different manufacturing and refining processes. And this was obviously poured out and stayed in one big 28-pound blob. No wonder why there was no other things necessary. This is the pour. I don't know. But we've seen other ones where they are like splash forms, a little bit more dramatic shaped. Greg, we're going to go to you. Do you have any comment on this? I'm seeing big round things on here. These are not chondrules, by the way. And they're not hitchhikers.
Yeah.
Greg, what do you have?
The thing is, residing in Florida now, I see a lot of these rocks. When I'm out fossil hunting and stuff, you see these all over the place. A lot of it's like limestone and it's just weathered and covered with mold and algae and stuff like that. That's why it has that reddish appearance. And yeah, I see these all the time. That's definitely not anything meteoritic. Yeah.
Yeah, I think this is our biggest submission of the night. So
one more thing, you would expect a stone that large to actually have regmaglyphs on it.
Yeah.
And this just it's got a terrible texture to it. No offense to Chris, just not I don't mean terrible, I just mean non-meteoritic texture.
And when we say we want it to look different on the outside than on the inside, you're seeing similar features, similar matrix throughout the entire thing, and then as Greg said, you're seeing this yellow on the outside as more of a contamination from Florida. So that's not remnant fusion crust or anything. So and being it homogeneous throughout, I'm going to agree with the crew and say we have another unique piece of slag here, a 28-pounder. Meteorite or MeteorWRONG number 4. I think this is a repeat offender, aren't they? Right, baby?
Yes.
Noah B.
Okay, does anybody remember we had a video submission a few months ago and there was a cat cameo?
Oh, God, yeah.
That was Noah. So Noah's back. Okay, so this rock was found in a parking lot in Southwest Oregon. It weighs 18 grams. It is 2 halves of the same rock. It's 18 grams altogether. And Noah did he performed the tests, but they weren't performed on camera. So the results were a strong attraction to the magnet and no streak from the streak test. We really like to see those streak tests done on camera so we know that like the right material is being used, the right pressure is being applied. So Noah said that the rock feels really dense, and he thought that it was possible oriented shape. And he also mentioned that the interior and exterior are different, but Topher did point out it's backwards. Usually it's darker on the outside, lighter on the inside, but this one I think is the other way around.
Yeah, and we usually don't like two, like we said earlier, we don't like two rocks at the same time, but this is obvious. The same rock broke in two pieces and he was able to find both halves of it. I mean, they fit together. He found them and they weren't just next to each other. They were in the same area, but not like he didn't pick them up together. So that's why there's no doubt in my mind that these right here are the same, one and the same material. We do see, he mentioned the oriented shape.
See, I feel like the inside looks darker in the video than it did on the photos.
Anyone can stick their hand up if they want. I am not seeing a whole bunch of chondrules, but I am seeing a whole lot of Allison. What do you have?
I also am not seeing a whole bunch of chondrules, but what I also am not seeing is metal. Why is this strongly attracted to a magnet? That is blowing my mind right now. Yeah, if I run through is it a chondrite? I don't see chondrules. Is it an iron? I don't see iron. Is it a, palisite? Definitely not. So I'm stumped about this. This is an earth rock, I'm sure, but why is it highly magnetically attracted?
Nice. All right. Well, you can't solve this mystery, Sherlock. What about Pat?
So this was found in a parking lot, and common in parking lot are tar or asphalt. And so the black stuff that's on the surface kind of looks a little splattery. And there is a good test for this. You heat up a needle until it glows and then touch it down on the black stuff. If it smokes or you can smell something, it's not fusion crust, it's asphalt. On rocks attracted to magnets, one could fill up many dump trucks full of earth rocks that will attract a magnet and still not have a meteorite. So iron is everywhere, and it doesn't. So in a lot of these rocks, the iron is not metal; it's bound up with oxygen or something else, and so there are metal atoms there, and enough to attract a strong magnet, but not enough to be metal.
Now, I do want to come at you from the rock counter point of view. Well, just because it has asphalt on it doesn't mean it's not a meteorite that was run over by a car. So, Dave Pinsky, do you want to take that up or you want to say something else?
Yeah, I would like to take that up because there's a few things that weren't mentioned. One, what is thought to be fusion crust is just almost like a desert varnish type of thing. There's no, it doesn't look like any fusion crust I would know. And when you look at the interior, it is reasonably fine grained. And I usually in a meteorite, unless it's one of those really rare ones, you see more grain to it. And I don't see a lot of grain. This looks like a rock that's been tumbled in water for a while and ended up on the pavement.
Yeah, I agree, and I'll give my 2 minutes to Daniel.
Thanks, Topher. So everyone made some really good points already about this rock. So I just have one thing to add to that. When you look at the inside of that texture, it does look like a clean break, like a fracture. So this does look like some kind of at least natural rock, I would say. But of course, the location, given that we're in Oregon where we have a lot of volcanics, we have several types of metamorphic rocks, it doesn't seem out of the ordinary that you can have like either some kind of basalt or diabase, and you're just breaking along that surface, given how fine grained it looks, and given how it kind of has a sheen to it, if you see how the light goes off of
Yeah.
it. And
Yeah.
regarding the metallic minerals, in a lot of basalts you find magnetite, which is of course magnetic, so that would attract a magnet.
Fantastic summary. Thank you very much. Yeah, I'm glad I gave my 2 minutes up. I don't need them. That's awesome. So yeah, I think that's another strong ID by the crew. I didn't like the interior and the way it was broken and the way it showed off, as Daniel said, the sheen on the inside. And it's weird. Sometimes you don't know how to explain it. You just look at it and you go, wait, that's off. So yeah, good on you guys. Thank you very much for that help.
All right.
Meteorite number 5 is submitted by John P. JP. I've been calling him. So JP, hopefully we can get this identified for you. Sue?
Oh, thanks, Topher. Yes, John P. This was submitted to us recently, and it was found near Wrightwood, California, I believe, and in a mountain valley around 5,100 feet elevation. I believe, yes, I don't think I got the weight from him on that. The diagnostic, there were several tests that were performed on video. We saw the attraction to a magnet, streak test. I believe that there was a quartz test in there, and then electrical conductivity. And I was not familiar with some of this stuff, and I wasn't quite sure if it had the diagnostic value. So I talked to Topher and Pat, and they told me, well, it's not the normal test, but yes, it does. So I learned something new. So I'm thankful for that. So yeah, we're gonna watch the video. John did report that there were metallic blebs that after a few months had formed rust around them. So I thought that was pretty interesting.
Yeah. I thank you, babe. I basically edited a bunch of his video to put it together into a video for us today, to really get a good look at a lot of the testing that he did. And as Sue was saying, it's maybe not the most standard or the most high technical and scientific, but it's another data point. It's another something that we can now know that either rules in or rules out something. So I'm going to go through this and tell you what I see. I invite the crew to raise their hand as well. The moment I saw this at first, I was thinking, wow, those are really big crystals. The only big grains and crystals we see like that, the first thing that pops in my head is like an albright. So if I'm coming at this from John's point of view, I'm thinking it's an albright, but I'm not quite sure. It does have some really interesting looks to it as far as metal on the interior.
The first thing I thought when I saw it was that would make some gorgeous jewelry.
Yeah.
But if it's a meteorite, yeah, we wouldn't want to do that. But I think it's a really pretty rock.
And did you see that by his, look up here by his thumb. See that hunk of metal? Yeah, I at first when I saw this, I also noticed layering and shimmering in the plates, almost like a mica or something like that. You can see it in this here, but you can also see the metal. And this is a nice little look. You can actually see free metal in the rock with oxidation, as he called out, surrounding it. And then I noticed this right here is super chatoyant, if that's a word. It shows chatoyance. So you can see into it, and it's the fire within is what they call it. So that's something that's usually in olivine is really the only time I see that in meteorites. Allison, what are you picking up?
I almost thought maybe might be a lunar when I first saw it, but we are very fascinated by the inside of this, but I want to look at the outside just for a minute and just say that I don't see anything that just screams meteoritic from the outside of this stone. And that's all I have for now. I'd like to hear what the rest of the crew has to say.
What do you think of this scratch test producing a white chalk and a lot of it? This is not just a tiny little line. Have you ever seen a streak test go like this on a meteorite? Or like that looks like chalk to me. Like it's a very, very soft material. And so soft he can actually with his fingernail, okay? So here are some pictures that I point. You can see little things. I actually thought they were mica grains, but some of them may actually be metal in there. And I think this is a beautiful sample of whatever it is. But yeah, there's the outside, and Allison, I'm gonna agree with you there. I don't see much. There's not much there. This seems to be a weathering rind or a weathering artifact rather than cream-colored fusion crust. That's been very well preserved. Ben, what are you seeing?
The only thing that really catches my eye is all the silica. There's way too much silica for a meteorite. That's all I've got.
When I first saw this right here, I didn't know what I was looking at. I literally thought he was putting dishwashing soap on his rock. And I'm like, I don't know what, I mean, okay, good for you, man. It's nice and clean. No, but I actually learned that this is a test for quartz. We can see that it is bubbling, and I guess that means it is negative for quartz. Now, this is another unique data point that was collected. The metal bleb, we'll just call it a bleb, is actually conductive. It is, and then here's another one. So it's able to conduct electricity or pass an electrical charge. Actually, I think what he was showing is on this one is not. So some are and some aren't. We're going to have Pat talk a little bit about the tests that were done. We're really at a disadvantage not talking about the tests and understanding what we've seen. So science, Mike, Pat, drop, whatever you are. How are you, man?
Well, thank you. So when we look at rocks and when we look at trying to identify meteorites, one of the biggest questions is that metal? You know, we see things that are shiny and kind of look like metal and have metallic luster, but not all of them are metal. And so the metal that is in iron meteorites is most generally, you know, a nickel iron alloy, or mixture of nickel and iron, and it in fact does conduct electricity. So an ohmmeter, well, an ohmmeter measures conductivity, and you know, metals like copper and iron and silver and so forth will conduct electricity. Things that are insulators won't, and we'll see that in our live demo here. So an ohm is a unit of electrical resistance.
What you're actually measuring, Pat, you're measuring the resistance to electrical flow in that metal. If
Yes.
it was infinite, meaning there it has infinite resistance. Electricity cannot flow through it. The lower the resistance, the easier the electrons flow through the metal, correct?
Yes, exactly. And then on the next slide, so some meteorites contain metal, and that metal will conduct electricity well. So we see that in iron meteorites. We also see it in pallasites, and we see in some stony meteorites with little metal inclusions that those little inclusions will conduct electricity as well. So, a general rule of thumb is, less than 10 ohms or so. Yeah, we're looking at metal. Greater than that, maybe not. And we'll have one new thing to show there too. Terrestrial rocks and minerals are very poor conductors. They're actually insulators. And because we have so much water and so much oxygen on Earth, the metals get oxidized, iron rusts, and so they don't conduct electricity well. Not all meteorites are metallic. The differentiated meteorites, the metal ran to the middle of the body. And so achondrites contain little or no iron. Some terrestrial materials also conduct electricity. Man-made metals, we talked about. Smelting slag oftentimes has little bits of metal because the smelting process is turning ore, generally oxides, into metal. Graphite, like we use for pencil lead, conducts, and some sulfide minerals, particularly iron sulfides, will conduct, and we'll see a bit of that in just a minute. Now, the ohmmeter test is not a test for nickel. It's only, is it or is it not an iron? And it is not a definitive test for meteorites. There are many earth rocks that have native metal. Native iron is pretty rare, not unknown. Most earth rocks and minerals are poor conductors of electricity, and so they will show a high electrical resistance. Low resistance may indicate potential metal. Doesn't necessarily mean it's a meteorite. It's not a conclusive test. A whole bunch of other testing is required.
Thank you very much. I appreciate you sharing this with us. Like I said earlier, it's another piece of data. It's another bit of information, and you keep on adding these bits of information, observations together until you can come up with a hypothesis of exactly what it is.
Exactly. Okay.
You're going to do a live demo for us?
Yeah. So we've got an ohm meter, and it has, 2 test leads. And when we connect those test leads, we see the resistance drops to less than an ohm. Okay, and here we have a kind of a, little rusted slice of a palisite. So we've got olivine crystals, and then we've got metal around it, nickel iron. And so if we touch down in a couple of spots, we can see that the resistance goes to less than an ohm. Now, if we try and touch down on one of the olivine crystals, no electricity can pass through those. So let's look at some other meteorites. So here is a slice of a ordinary chondrite that has metallic blebs in it. And this is a little fussy, but there we can see that is, we can see that it's conducting electricity. And I'm having trouble staying on that little bit of metal. There we go. There's a good one. Okay, so we're less than an ohm. So mostly we're looking for metal in meteorites, but other things do show up that have a metallic luster. So this little bit here is a bit of, this one over here is a bit of iron sulfide or troilite. And if we touch down on that, we're seeing, we're seeing about 5 ohms. So, so sulfides can conduct electricity, and these iron sulfides in meteorites will do that. And then this is a slice that's near and dear to Topher's heart. This is one of those high metal ones that he loves so much. And even from a little ways away, There we go. So, a few megohms, which means that those little individual metal grains in some places are touching each other, and we can get conductivity over a longer distance. So this is a test for metal, but not a definitive test for meteorites. And in general, unless we're talking about copper, silver, gold nuggets, in general, it's hard to find metal in earth rocks. But there are a lot of things that look like metal, like mica, like hematite, like magnetite. And this resistance test will point those out for us. And that's what I had, Topher. Thank you.
Thank you very much, Pat. Appreciate you knowledge dropping and mic dropping on us. I am really thankful not only to the crew for every week supporting us so well with these rock IDs. It's a collective brain share, and we can't do it just with one person. So thank you, crew. Really appreciate it. And we couldn't do it without our Patreon sponsors and supporters. So thank you very much. I really appreciate it. Sue, I think a couple people just crossed over 2 years of support. That blows my mind. 2 years supporting us. Do you know who I'm talking about?
Yes, yeah, we're coming up on 2 years. The oldest member, or our very first, was the Ozerky Turkey.
Nice. Art Wagner. He is the oldest.
I didn't mean oldest.
He's the most
membership.
veteran and the oldest.
And then right after Pat, we had Dr. Ralph and Chris Monk join. So they're all at the
Art,
2
Pat,
meteor
Ralph,
mark.
and Monk. Wow. So thank you guys very much. That's 2 years of your support. We really appreciate it. A lot of people are coming up on 1 year of support as well. And at the end of the video, in case you guys haven't figured it out, I don't know what's wrong with you, but when the video ends and everyone's name is showed, if you have a meteorite or a meteor next to your name, that's a year. If you have 2 meteors next to your name, that's 2 years. And then
Topher, let me give you 3 more names.
Oh.
Yeah, we have coming up in October, we have Jim and Smiley will be 2 years. Jules will be 2 years in November, and Maxine will be 2 years in December. And we have lots of 1 years as well. So
that's phenomenal. Yeah, we're building something strong here. And as we were told today, no one else is doing this. So we really hope that you got the submitters today, your Rock Count supporters got your Rock ID. I hope you feel a little bit better about what you have. And hopefully you'll join us on Patreon as a supporter. You can go to Patreon and join as a Rock Counter for $25 a month or for $10 a month. Or you can just join for free and get access to some of the stuff. So go out there, check out Patreon, see if it's what interests you. We put a lot of work into it. So thanks a lot, guys. Have a great week.